Hello students, good evening to all of you. So here I'm going to discuss some of the problems of degrees of freedom from classical mechanics. So a particle is constant to move on a circle, the number of degrees of freedom. So इसका जो आंसर है वो है option B, that is 1 degree of freedom, because whenever we have a particle on a circle, like this is the position vector, we can say that this is the position of particle, it having coordinates x comma y. So we know that x is equal to, let's suppose it is making an angle of theta, so x equal to r cos theta and y equal to r sine theta. So with the knowledge of that theta we can, because this r is fixed there, this radius is fixed, so with the knowledge of theta we can easily calculate the x as well as y there, because r is fixed there. So definitely only one coordinate or is being required to specify the position of the particle on a circle. So basically 1 degree of freedom is there. Then mosquito move on upper surface of a hollow sphere, the number of degrees of freedom. So mosquito is basically on the surface of a sphere. So in case of sphere we use the spherical polar coordinates, that is r, theta and phi. So but r is fixed there, so we have to utilize two of the coordinate to specify the position of the particle on the surface of hollow sphere, that is theta and phi. So number of degrees of freedom are 2. So 2 is the answer for the second problem. So then we have there are 6 particles on a plane. The degree of freedom are, so basically there are 6 particles, but there is nothing being mentioned in the question that like particles are separated, or like particles there is some separation between the particle are joined. So there is nothing like that. So only there are 6 particles on the plane. So for a single particle on a plane we require 2 coordinates. So for one particle we need 2 coordinates there, yani ki 2 degrees of freedom there. So it means that we have 6 particles. So for 6 particles to specify them we need 6 2s are 12. So there are 12 coordinates are required there. So basically answer of degree of freedom is option C, 12. Thank you.